Hi everyone, this will be our last video. I'm going to go over the review for homework 24 for acids and bases, and then you'll take your last test. So I just wanted to say thank you so much for hanging in there this year. It's been really different, and I really appreciate your hard work and your ability to self-motivate, and it's just been nice to still connect with you, even though we haven't been able to see each other in person. Hope you have a great summer, and for those of you taking AP Chemistry, I'll see you this summer in our Google Classroom and next year, and everyone else, I'd love to hear from you in the future. Take care, you guys. And here is our last lesson where I will go over the review. Homework 24, review acids and bases. So yeah, here's my thank you. It has been an unforgettable year. I'm going to go over the review homework, and then we have the Unit 9 exam, acids and bases. You'll do on Go Formative. So before your last test, here's how I would have done the homework. There's the reference tables we might need as we go over this. All right, so homework number 24, review for the Unit 9 exam, acids and bases. For each characteristic, number 1 through 5 below, categorize it as an acid, base, both, or neither. So I'm thinking about lesson 9.1, characteristics of areneous acids and bases. So producing hydronium ions in water, number 1. Hydronium is on reference table E, your selected polyatomic ions. It means H3O+, and the presence of H3O+, or hydrogen ions, H+, both indicate that you have an acid. Sorry, A for acid. If it had been hydroxide ions in water, OH-, that would tell me it were a base. All right, reacts with a metal. That must be an acid. Conducts electricity. That could be an acid or a base. So, all right, both. Turns litmus paper blue. Well, if we look at our reference table here, we can see that litmus goes from red to blue in a pH range of 4.5 to 8.3. So if it's at the blue end of the range, that means it's 8.3 or higher. So that means it's a base. If it tastes bitter, that also indicates it's a base. Bases taste bitter and feel soapy, while acids taste sour, like lemon juice. Bitter, you can think of like baking soda, the base. All right, number 6, do areneous acids and bases always form ions in aqueous solutions? Yes, they do. We can tell because they conduct electricity. Or you could say because they're electrolytes. Seven, in an aqueous solution, which substance yields hydroxide ions as the only negative ion? Hydroxide ion, which is on table E, your reference table, selected polyatomic ions, that indicates a basic substance. So I'm looking for which one of these is a base. These all have an OH at the end, though. How confusing. Are they all bases? No, only one of them is a base. So why is only one of them a base? Well, one of them is on your reference table. Oops, this one. Common bases. Calcium hydroxide, so that's one way you can answer this question. The other way is to look at the fact that all of these are all made of nonmetals. So that means we have only strong covalent bonds here, so it will not make any ions in water. Whereas this has a metal and a nonmetal, so that bond here will break, and that will make ions in water. So that one will make hydroxide ions in water. And stop doing that weird thing. Okay. 8, gaseous carbon dioxide is a non-conductor, but aqueous carbon dioxide is a conductor. Use your knowledge of chemistry to explain why this is so. So if something is a conductor, that means it's either an acid, a base, or an ionic compound. Carbon dioxide is not ionic. It's not made of a metal and a nonmetal. So that means it must be an acid or base. And when we look at the reference table here, we can see that it is an acid. So gaseous CO2 is a molecule, is not an acid, base, or ionic compound. It's a covalent molecule. But CO2 aqueous is an acid, so it conducts. So number 9, fill in the blanks. Stronger blank produce more ions when dissolved in water, thus making them better blank. So I'm going to fill in this blank with stronger acids and bases. Strong bases produce lots of ions in water, and strong acids produce lots of ions in water, and that makes them better conductors or electrolytes. Okay. Fill in the blanks. Acid plus base produce blank and blank. Acid plus base, that's a neutralization reaction that makes water and a salt. What is salt in chemistry? Salt actually just means ionic compound. And in a neutralization reaction, it's always the leftovers from the acid and base that are not the H plus or the OH minus. Okay, what do you call this reaction of an acid and base? It's called a neutralization because it neutralizes the acid and base, and the products, water and salt, have a pH of 7, neutral. 13, a 50 milliliter sample of hydrochloric acid, aqueous, is neutralized by 64.2 milliliters of 0.15 molar sodium hydroxide aqueous. What is the molarity of the hydrochloric acid? Well, here we have a question with a bunch of numbers. That means we need an equation. And since they say neutralized and they mention an acid and a base, neutralized, that means we can use the titration equation. This is on the back of your reference tables on table T. MA times VA equals MB times BB. Okay, so in this case, this first number they're giving us, 50 milliliters. Milliliters is a volume. Hydrochloric acid is an acid, so this is VA. Next number, 64.2 milliliters. That's milliliters is volume, and sodium hydroxide is a base, so this is volume of the base. And here, 0.15 molar is the concentration of the base. So that's molarity of the base. And they said, what is the molarity of the acid? So they're asking for MA. Okay, so we know how much base it took to neutralize it, and we know the volume of the acid, and we know the concentration of the base it took to neutralize it. So we can figure out how concentrated this acid is by putting in numbers for everything else. The volume of the acid is 50 milliliters, and I'll just leave in the units this time so we can see how they cancel. Molarity of the base is 0.150 molar. Volume of the base is 64.2 milliliters. Let's divide both sides by 50 milliliters to get the molarity of the acid, the unknown, by itself on one side of the equal sign. So here that's going to cancel. Milliliters are going to cancel. So we have 0.15 molar, 0.15 molar times 64.2 over 50. I get 0.1926. Looks like I've got 3 sig figs in all my numbers, so I'll use 3 in my answer. So I'll say 0.193, and the only unit I have left is molar, for the molarity of the acid. Okay, number 14, which volume of 0.1 molar sodium hydroxide aqueous exactly neutralizes 15 milliliters of a 0.2 molar nitric acid solution? Okay, we've got another titration problem. So I'll use the same equation here. NaVA equals NBVB. And let's see if we can identify all the variables. So here we've got 0.1 molar of sodium hydroxide, which is a base. So that's molarity of the base, MB. Here we've got 15 milliliters of HNO3 nitric acid, so that's a volume of the acid. And here's the concentration of the acid. So that means we must be looking for the only thing we don't have, which is VB. And it says which volume of sodium hydroxide exactly will neutralize that much. So let's solve for VB by putting in numbers for everything else. MA is 0.2, VA is 15 milliliters, MB is 0.1 molar, and VB is what we're solving for. So to get this variable by itself on one side of the equal sign, we'll divide both sides by 0.1. So VB equals 0.2 times 15 over 0.1. So you can do that in your head. I got 30. So choice D. Okay, for questions 15 to 16, refer to the passage below. In a titration, 15.65 milliliters of a potassium hydroxide solution exactly neutralized 20 milliliters of a 1.22 molar hydrochloric acid solution. 15. Complete the equation for the titration reaction by writing the formula of each product. Great, so it looks like we've got a neutralization here. And we know that acid plus base make water and salt. So acid, HCl plus base, KOH, make water. And then the salt will be the leftovers. So the acid gives away the H, the base gives away the OH. So we have left KCl. That's our salt. 16, calculate the molarity of the solution. Well, this is a titration, so we'll use the titration equation. And this time, here they give us a milliliters of potassium hydroxide, that's volume of base. They give us 20 milliliters of hydrochloric acid, that's volume of acid. They give us the molarity of the acid, MA. So we must be solving for MB. And in fact, they say calculate the molarity of the potassium hydroxide solution. So we'll put in numbers for everything else. MA is 1.22. VA is 20 milliliters. I decided to leave in the units again this time, just for fun. Volume of the base is 15.65 milliliters. Okay, we'll divide both sides. 15.65 milliliters to get the unknown by itself. And you can see when I use the units that milliliters cancel, so you don't have to change milliliters to liters or convert, which is really nice. Okay, so we're left with 1.22 times 20 over 15.65. And that gives me 1.559105431. Okay, and our unit, but we obviously can't use all those digits, so let's look up here. We've got 4 sig figs in that number, 3 in that number, 4 in that number, so I'm limited here. I'll use 3 in my answer, so that will be 1.5, round that guy up because the 9, 6, and our unit is molar. All right, 1.22 times 20 divided by 15.65. Okay. All right, 17. A solution was found to have a vastly larger number of hydroxide ions than hydronium ions. What might be its pH? Okay, if the solution has more hydroxide, that means it's basic. And on the pH scale, it goes up to 14. 0, this is acid. 7 is neutral. And then anything above that is basic. So if this has more hydroxide ions, it's basic. It's something above 7. So the only answer can be C. A solution was pink in phenolphthalein and turned colorless with the addition of a few drops of a dilute solution. What is its most likely new pH? Okay, so let's look at our common acid base indicators. Phenolphthalein, it says it was pink, so that means it has a pH of 9 or above. Then it turned colorless with a few drops of a dilute solution. So it was 9 or above, and now it's less than 9, 8 or below. So most likely the pH is just a few drops. It's probably neutralized at 7. If they said with the addition of many drops of a concentrated solution, then I might have picked 4, meaning, okay, they kept going and now it's really acidic. Okay, 19, the hydrogen ion concentration of a solution increases by a factor of 10. By how much does its pH decrease? So every change on the pH scale is a times 10 change in hydrogen ions. So its pH will decrease by just 1. Number 20, a certain solution makes methyl orange turn yellow and bromothiamyl blue turn yellow. What are the upper and lower pH limits of the solution? Okay, so here's methyl orange. When it is yellow, that means the pH is 4.4 or above. Bromothiamyl blue, when it's yellow, that means its pH is 6.0 or below. So this must be somewhere between 4.4 and 6 for pH, approximately. All right, have you guys ever seen these flowers? Maybe you have them at your house. Hydrangea, they can be different colors depending on the pH of their soil. So if you see these in the future, you can figure out their pH indicator, what the soil is like that they're growing out of. For problems 21 to 22, we're going to refer to the passage below. Soil pH can affect the development of plants. For example, a hydrangea plant produces blue flowers when grown in acidic soil, but pink flowers when grown in basic soil. Evergreen plants can show a yellowing of foliage called chlorosis when grown in soil that is too basic. Acidic soil can be neutralized by treating it with calcium hydroxide, CaOH2, commonly called slaked lime. Slaked lime is slightly soluble in water. So question 21, compare the hydrogen ion concentration to the hydroxide ion concentration in soil when a hydrangea plant produces pink flowers. Okay, so what did they say about pink flowers? They said It has pink flowers when grown in basic soil. So pink means basic. Now the question said to compare the hydrogen ion concentration to hydroxide ion concentration. So if it's basic, there's more hydroxide. So I'm going to say more hydroxide than hydrogen ions. Remember in these questions, when the question seems really complicated and long, that often means that the answer is very simple and short. All right, number 22. Write an equation using symbols or words for the neutralization of the ions in acidic soil by the ions released by slaked lime in water. All right, we're writing an equation using symbols or words for a neutralization of the ions in the acidic soil by the ions released by slaked lime in water. Okay, first I'll do it in symbols and then I'll do it in words because you can do either way. So the ions in acidic soil are going to be H+ ions, because H+ is what you get from an acid. By the ions released by slaked lime, that'll be the hydroxide ion. The slaked lime is this guy, the base. And that makes H2O. Or if you wanted to do it in words, you could say acidic soil ions plus slaked lime base make water and a salt neutralization. Okay, for the remaining questions, imagine that a student began the same kind of tration that you did virtually, trying to find the molarity of acid in a contaminated river, as in the setup shown below. In this case, in each trial, 25 milliliters of acidic water was titrated using 2.5 molar potassium hydroxide aqueous. Their data also appears below. So it looks like the initial volume reading of 2.5 molar potassium hydroxide aqueous in the burette in milliliters was 11.40. The final volume reading was 23.61. And observation, it turned light pink as base was added. Okay, so imagine that the data shown above, this is number 23, is what the student got on their first trial. According to their data, what is the concentration of acid in the river? So concentration of acid, they're asking for, what is MA? So let's use the titration equation. MAVA equals MBVB. All right, we're solving for MA. That means we need numbers for all of the other three. So MA times, let's see, what's VA? Volume of the acid. Ooh, here it is. 25 milliliters of acidic river water. All right, what's MB, molarity of the base? Oh, here it is, 2.5 molar potassium hydroxide. Okay, volume of base. Well, we've got the initial volume and the final volume, so if we subtract, we can find the volume of base used. So 23.61 minus 11.40. 0 is 1. 2, 3 minus 1 is 2, 2 minus 1. 12.21 milliliters. And now we'll just solve for MA by dividing both sides by 25. So I'll just do it on my calculator. 2.5 times 12.21 over 25. I get 1.221. Looks like we've got only 2 sig figs here, so I'll say 1.2 molar. Number 24, why do you think the solution turned pink towards the end of each trial? Well, they were clearly using an indicator, right? And we can look at our reference table. Which one turns pink? We must have been using phenolphthalein indicator, which turns pink as it becomes basic. So why do I think the solution turned pink towards the end of each trial? Well, we started off with an acid, phenolphthalein is colorless in an acid. And turns pink at a pH of 8 or above. So as the base was added, it started to was neutralized and then moved into tiny bit basic, and that's when it turned pink. Okay, number 25. Below are shown 3 models of potential different moments in a student titration. Using the key provided, categorize each diagram below as a model of either before the acid was titrated, after the acid was titrated, or when the acid was over titrated. Okay, so let's see what we have going on here in each model. So in the first one, looks like we've got a H2O water molecule, hydroxide ion, and 1 hydrogen atom. So there's exactly as many acid as base ions. So this one is neutral. So I would say that this is after the acid was titrated. Acid was titrated because it's neutral. Okay, in this one we've got a whole bunch of hydrogen ions and just 1 hydroxide. So this one is acidic. So this must be before the acid was titrated, when it was just an acid in there and hardly any base. And then this one, we've got hydroxide, 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 and only 1 hydrogen. So this solution is basic. So that means they actually added too much base. They neutralized it and then kept going. It got light pink, then dark pink, then really dark pink, and they just kept adding more base. So this one was over titrated. They went to the neutralization point and kept going. Awesome, you guys. So that was how I would do the review homework. Your test is on Go Formative. It is open note. You can use your reference tables. You can use a calculator. Please do make sure that you are doing your own work. Best of luck. Thanks for a wonderful year.